Welcome back to the Moralis channel, everyone. In this video, I'm going to show you everything you need to know in order to create an NFT, how to list it on Opensea, how to use Moralis to interact with your NFT, how to deploy NFT metadata, everything you need to know in order to launch your NFT. And as I said, we're going to start by actually creating it using Solidity. So we're going to build the smart contract, but it's going to be quite easy because we're going to use OpenZeppelin libraries to do that. It's going to be an ERC 1155 token. And then I'm going to show how to deploy that to a real live network together with all of the metadata like image, like text, description, attributes, things like that. How to deploy that metadata and how to do it in a way that is compliant with the ERC 1155 standard, so that when we then in this tutorial go and list it on Opensea, a big NFT marketplace, they are going to automatically pull in all of the metadata from our smart contract, from our NFTs, and it's going to display on Opensea with image, with description, with title, all of that stuff. But the video is not over there. We're going to continue. We're going to use Moralis to build an NFT manager, a place where we as NFT owners can manage our NFT. So here we've built this using just a few lines of code with Moralis and some simple JavaScript, where we can see all of the NFTs that we have minted in our smart contract. You can see an amazing photography of my home city of Stockholm. You can see an artwork that I drew myself. And you can see the title, the description, how many are in circulation, how many owners there are, how many I own personally in this address currently. And then we're also going to build this mint and transfer functionality. So I, as a contract owner, will be able to go into mint. I can mint a specific token ID. I can mint a specific amount to a specific address. Then we can also do the transfer function. So we can select the token ID you want to transfer, the amount we want to transfer, and to the which address you want to transfer it to. All of this will be done using Moralis, and it will be very simple, few lines of code, and then the rest of the JavaScript to pull together a website like this I'm going to show you. But it's going to be an exciting journey where you're going to learn a lot about NFTs, a lot about NFT metadata, how to host that, a lot about the ERC 1155 token standard, and of course a lot about Moralis. I hope you're excited. Now's the time to get started. If you're excited about this, make sure to not only like the video, but also to join the Moralis Discord and become a Moralis mage. Become a part of the community, because there, when you become a Moralis mage, you join our Discord, you will also be able to get a lot of help from the community, a lot of inspiration. Maybe you can find some friends, some developers that you can build stuff together with. So make sure to join this amazing developer community. You can find the links down in the description. With that being said, let's get started. So we're going to start with an overview, because what we need to do, first of all, is to create the smart contract. The smart contract. And the smart contract is going to keep track of really only one thing, and that is the owners of the NFT. Because what the smart contract does is that it maps a unique ID of your NFT to one or more owners. So if you decide to, let's say, create two unique NFTs, you give them ID 0 and you give them ID 1. The smart contract is going to keep track of who is the owner of NFT number 0, who is the owner of NFT number 1. And that is going to be available across the entire blockchain for anyone that is looking into that, so that that person who holds that NFT can prove that to other people. They can hold it in their wallet. That is what the smart contract is for. The smart contract will also provide the necessary transfer functions so that you allow people to transfer the NFT. And usually this is in regards to a purchase. If someone wants to sell their NFT, they also need to be able to transfer it. So the transfer function in an NFT smart contract will transfer NFT from one address to another. And the only one that can initiate a transfer is, of course, the previous owner. But this smart contract, the actual token contract, which this is, does not handle the actual buying and selling. That is done by a marketplace. And a marketplace is usually another smart contract, but it also has a user interface, like a website, where you can trade NFTs, right? And this is places like OpenSea, for example, or Rarible. There are other places as well. These are the ones that I'm mostly familiar with. And in this guide, we're going to list our token on Opensea. And I'm not related to Opensea in any way. Moralis is not either. It's just the one that I'm mostly familiar with, and I know how to list tokens there. So we're going to use Opensea, but we have no relationship with them whatsoever. And that is the NFT marketplace, and that's very different from the smart contract. So that's important to know. But the marketplace interacts with the smart contract. And of course, the opposite is true as well. The smart contract will interact with the marketplace. So that, for example, when someone wins an auction in the marketplace, that will initiate a transfer in the smart contract so that the NFT switches owner. Another thing that we need to cover is, and you're probably asking yourself, where does the actual interesting parts lie? Because with an NFT, you usually have an image, right? You have a name of the NFT. Maybe you have a description. And maybe you have other attributes. And the question is, where are these things saved? Because I can tell you straight away that they're not saved in the smart contract. So apart from these two services, there's one more thing that we need to figure out, and that's where to host our metadata. Because this is called metadata, what we just discussed. Image, description, name, attributes, that is called NFT metadata. And we need to figure out where to host our NFT metadata. Let me write that here. NFT metadata. And this data will be pulled in by the marketplace automatically because it follows a specific standard, a specific schema, so that when the marketplace queries NFT ID 0, for example, it will be able to look up the NFT metadata for that specific NFT. And that is done because the smart contract will save a URI. It's like a URL, like a web page. So for token number 0, there will be a web address saved in the smart contract that the marketplace can look up and see, okay, here's the image, here's the description, here's the name, and here's the attribute. But it's not hosted on the blockchain because, for example, an image, or maybe you want a video, that takes up way too much space to be in the blockchain. So the blockchain only keeps track of the ownership, while you use some sort of external service. We're going to use Moralis to host the metadata, like image, description, name, attribute. And then there is a link embedded into the smart contracts for each token. So you can query easily the metadata for token ID 0, for token ID 1, and then you can display a nice image here, whatever that is. So we're going to start by building the smart contract, and then we're going to move on to doing the metadata and hosting that somewhere. And finally, we're going to list it on the Opensea marketplace where we can get bids for it, okay? And that's it. So with that said, let's get started with the actual smart contract. And to build the smart contract, we're going to use Remix, because the smart contract, even though it sounds difficult to create an NFT smart contract, it's actually not that difficult on the smart contract level, because we have so many great libraries these days, and we're going to utilize that when we build our NFT. So we're going to use remix.ethereum.org to build this NFT contract. And what you want to do first of all is to create a new file here in Remix, and that is done here. We're going to create a new file here let's call it Opensea NFT _NFT.sol. And the name here doesn't matter, it's just for organization purposes here in Remix. And then we're going to start. I assume that you do know some Solidity before this, so we're going to start by pragma Solidity 0.8.0. So this is the compiler version I want to use. And now we need to import the ERC 1155 token contract from OpenZeppelin. And OpenZeppelin is this fantastic library of token contracts and other contracts, just useful contracts overall that you need a lot when you're building, you know, it's common functionality for smart contracts. OpenZeppelin provides those kinds of contracts, and they're well tested, well used, so they're considered safe. Nothing is 100% safe, of course, but they're considered very safe. And let me show you here, first of all, where we find these token contracts. So here I've googled for ERC 1155 OpenZeppelin, and ERC 1155 is the token standard that we're going to use for our NFT. There are basically two NFT standards nowadays, ERC 721 or ERC 1155. And 1155 is a newer standard. It is a bit more flexible. You can do both fungible and non-fungible tokens in the same contract. You can do things like batch transfer. So it has more functionality and it is a little bit more effective. It can also be a bit harder to work with. It's a bit more complex. But I think for this tutorial, we're going to go with the newest token standard for NFTs. So here you can see the OpenZeppelin GitHub page for the ERC 1155 contract. And this will give us all the functionality that we need. It will give us the necessary mapping to keep track of the balances. It will give us all of the functions we need in order to check balances. For example, here we have balance off. It will let us do transfers, so we have transfer from. And it will give us the functionality to mint new NFTs. We can mint batches of NFTs. We can burn NFTs. So there's a lot of functionality here. And we're not going to implement all of them, but we're going to implement the most important ones. So how do we then take this contract and create our own NFT from it? Well, first of all, we need to import this contract into our smart contract. So we write import, and then we can just take this GitHub link. Remix is that smart. We can just take that link here and import that. And then we can define our own contract. So we're going to call this NFT contract. And we're going to inherit from this ERC 1155 contract. That's how we will get the functionality from this contract, is by inheriting it. And if you haven't, if you don't know about inheritance in Solidity, or you need to sort of refresh your memory when it comes to Solidity programming, check out some of the Solidity videos on this channel. We have fantastic tutorials and other videos on this channel about Solidity programming, so make sure to check that out. And now all we need to do is start implementing our own NFT based on this parent contract ERC 1155. And we can start by defining first a list of the items that we want to have. And we're going to define those as constant integers. So we're going to create unsigned integers. And let's see here, public, and they're going to be constant. And then we need to name this something. So what is our first item going to be? Let's just call this artwork, okay? I'll name this piece artwork, and I will give it ID 0. So my NFT that I'll call artwork, I give ID 0. And then let's create another one just so that you know how it works. What should I call this? I can name this photo. So I have one artwork and I have one photo, whatever that means. You can name them whatever you want. These names are just for internal use anyway, so they're not what will be displayed on OpenSea or on the marketplace. But it can be a good idea to keep them the same, because otherwise you might be confused, or your developers might be confused. And then we're going to define the constructor, which is what will mint the initial versions of these two NFTs. And we need to call the constructor of the ERC 1155 contract here as well, the constructor of our parent contract. And then inside here is where we will mint these two NFTs. So we will call the underscore mint function, which is a function in our ERC 1155 contract. As we can see here, if we search for underscore mint, you can see that it takes an account. It takes the ID that we want to mint. And you can see here, if you read the description, creates amount tokens of token type ID and assigns them to account. So we need to specify account, ID, and amount. And then there is a fourth argument here, bytes memory data, which is just for sort of internal notes or internal purposes. So we're not going to use this, but the three first arguments we need to pass in. And the account will be the initial owner of these NFTs. So we will mint them to ourselves, which will be message.sender. That will be the creator of the contract. And then the ID they want to mint. So that will be artwork, because that is equal to ID 0. And then finally, how many we want to mint. We want to mint 1, let's say. Was this the right order? ID, amount, yes. And then, yeah, we need to put in empty data as well, an empty string. And then we're going to do this one more time because we want to mint 2 NFTs. We also want to mint the photo NFT. And this, I want to mint 2 of those. So I have 1 artwork and I have 2 photos that I want to mint. And the last thing that we're missing here is that the ERC 1155 constructor, if we search for that here, takes a constructor argument called string memory URI. And this is the URI that we talked about here, the URI to this metadata. And here we need to provide where our metadata will be hosted. And we will wait and input this until we have finished the smart contract, and then we'll get to work on the metadata. And once we have figured that out, we can input the link here and deploy it. But we're going to finish writing the smart contracts first. And now this is actually enough for a fully functional NFT. The problem with this specific NFT now is that once we have minted these, we can't mint any more NFTs. So what we might want to do is to build a mint function that allows maybe us as owners to mint more NFTs in the future. So we're going to do that. And as you remember, the And as you might remember, the 1155 base contract that we had here, it has a function called _mint. But this is an internal function, so it's not available to be called from the outside. So this is something that we can wrap around. So we're going to create function mint, going to be public. And this, in turn, will call the _mint function that is available through our parent contract. And we need to take the same arguments, address, account, amount, and ID. So I'm going to copy that inside here. Since we don't use the data thing, we don't need to input that here. And all that we're going to do with this data is to pass that along into here. Account, ID, amount. And then we also need to pass in the empty data. Okay. Now, this would work. This would mint new NFTs with whatever ID we input, whatever amount, and to the account that we specify. The problem is that this can now be called by anyone that wants to call it. It's publicly available. We don't have any restrictions on it. So now it can be called by anyone, not just the owner, because there are no such restrictions here in this function that we're calling. And this function, all it will do is that it will make a few checks, and then it will increase the balance of the account that minted the NFT, and it will emit an event that the transfer has been complete. So we need to add a require statement here that makes sure that this function can only be called by the owner. And to do that, we're going to use the OpenZeppelin ownable contract. So if I open this up here, no, contracts. Contracts, access, ownable.sol. I want to implement this as well. So I want to import that into my contract here as well. Import this. And you can Google just for OpenZeppelin ownable to find it also. And then we're going to say that this also is ownable, because that will allow us to say that this should only be, let's see, what do they call that? Only owner, right? So we can set only owner here, meaning that the mint function will only be accessible by the address that deployed the contract initially. That is what this ownable contract will do. It will save an address of the owner, and then it will implement this modifier, only owner, that we can put on our functions. And once again, if you don't know what modifiers are, you should take some more Solidity courses maybe, or tutorials, but it's a snippet of code that gets run before our function gets run. And in this case, the only owner modifier will run and make sure that the caller is actually equal to the owner. So that means that this function can only be executed by the creator of the contract. Now we have a working mint function. If there's any other functionality that we want to implement, we need to do that now. So maybe, the transfer functions, they are already public, but maybe we want to be able to do burn, for example, which in that case, we need to implement the public burn function. So let's do that here as well. Function burn. Let's see what parameters that takes. Account and ID and amount. Add that here. And that's going to be public. And maybe in this case, the burn function should only be able to be called by the token owner. So you can only burn your own tokens. I guess that would be reasonable, right? The contract owner should not be able to just burn anyone else's tokens. But if you own the token yourself, then you should be able to burn it, I assume. And in this case, this functionality is already implemented in the internal function _burn that we're going to call. Because if we look this up here, you can see that before it actually does the transfer here, or actually it reduces the balance, because this is just a burn function, so it removes the token balance of that token. You can see that it checks so that it checks the balances for this token ID for this specific account, and it makes sure that the account balance is actually larger or equal to the amount that you want to burn. So all we need to make sure of is that the account that you're requesting to burn is actually the message.sender. Because otherwise you can say that you want to burn someone else's tokens. So make sure that message.sender is equal to account. Okay, that is passed in here. If that is true, then we can move on and call _burn for account, ID, and amount. Okay, so now let us try this out by deploying this on just a virtual machine here. So let's go ahead and go to this third tab here, select JavaScript VM, and then click deploy. Make sure you've selected the NFT contract here. Click deploy, and you'll get this instance of your contract here with all of the different functions that we can call. First of all, we can check, for example, the balance of. So our address, which is this one right here, should have gotten all the balances currently. So we can check our address and then comma. Can you see this? I can try and make it bigger, but it's going to be so big. Maybe I can do this. Oh yeah, here we go. Balance of. I can input the address and then token ID 0, for example. All, and it says that balance is 1. If I take ID 1, the balance is now 2. What if I want to do a mint? I want to mint to my address. I want to mint token number 1, the photo, and I want to mint 10 of those. Okay, let's check that out. So let's hit transact, and there it goes. And now let's check the balance again. All of a sudden I have 12. I can also mint the new token. So I can mint token number 2, which we don't have defined here. I can mint 20 of those, transact, and check the balance of token number 2. It will now be 20. But if I'm not the owner, so if I switch my address to another address and I try to mint this again, I cannot mint because it throws a revert, which means that I'm not actually the owner. So that works as intended. With that done, let's see if it's like that. With that done, we can move on to actually talking about the metadata, because now our contract is ready to deploy, apart from the fact that we need this metadata URI scheme, okay? And let me talk quickly about how that scheme works. So let's talk about what the metadata should look like. So for each NFT, we can provide a JSON string like this. So this is from OpenSea, but this is a general standard. We can have a description, we can have an external URL that maybe points to our project or wherever we want to link to for that NFT. We can have an image, which is very common. We can have a name, and then we can have an array of attributes. And these are just the most common ones. And you can have other things as well. You can have background color, animation URL if you want to have an animation. You could even have a YouTube URL. So the problem is that we need somewhere to host this little JSON string. Because we can't put it in the smart contract. It needs to be an external link to a JSON file of some sort. And what we're going to do then is we're going to put the link to that JSON file in our smart contract. But we need to have one JSON file for each NFT ID, okay? And the way we're going to do this is that we're going to create JSON files like this for our two NFTs, and then we're going to host them on Moralis using Moralis static hosting. And in order to do this, we simply need to open up a new folder somewhere in our editor and start creating these JSON files. So here we are. I have an empty directory here, and I'm going to create a new file. And first, we actually need an index.html file because Moralis won't allow you to host anything if it doesn't have an index.html file. We're not going to use this, so we can just put something here, hello, within these HTML tags, and make this bigger. Yeah, that's okay. Save that. And then now we can create our JSON file. So we're going to create a JSON file, and we're going to start by calling this 0.json because 0 is our token ID. And here we can put our actual properties that we saw in on the previous website, the OpenSea website. We can have image, needs to be image like that, and here we will have a link to an image. Then we should have description, again within quotes like this. And then what was the other name we should have? So we could call this. I think we're just gonna have name, image, and description. So what are we gonna call this NFT? You have to keep in mind that I'm a developer. I'm not a creative person for like artworks and stuff. So I'm gonna call this Philip's artwork. Okay. And I'm gonna give the description here: the artwork of a Solidity developer. And the question is the image. What should we have as the image? Because not only do we need to host the image somewhere, I actually need to have an image. So let us actually draw something, okay? We're going to save this for now, and then we're going to go back to my drawing pad here. I hope I can export this. So let me draw something nice here. And when I say nice, I don't mean nice at all, but just something that we can use. So I'm going to draw a nice face here. Like this, a smiley face. And then what more can I do? That's sort of the limit of my creative capacity. So let's leave it at that. And how do I export this? Let's see here. I hope that you can do something that's more download. Here we go. It's a bit more creative. So let me I'm gonna call this artwork. Okay, it'll be artwork.png. And then I need to have a photo as well. So let me find the photo. So I found a photo here of the beautiful city where I live, Stockholm, and I'm gonna use this one. And luckily, the photographer is my brother, so I hope he doesn't gonna get mad at me because I stole his photo for this tutorial. But let's see, we'll figure that out sooner or later. But let's go back to our code, and now we have both. Let me rename this to photo.png, and then we have artwork, or photo.jpg, artwork.png. Let's see which one will be worth more on OpenSea. And so now we have those, and that means that we can also get the image URL to this artwork, okay? And what I'm gonna do is that now we need to get the URL for this directory. So I need to host this directory so I can get the link to the artwork and the link to the photo and then put this here. So what we're going to use the Moralis CLI. So you need to open up your terminal. You can go to view terminal, and then we're going to run npm install -g moralis -admin -cli. And I've already installed this, so I'm not going to run this, but you should run that. And you also need a Moralis account, by the way, because when you're going to host this, you're going to run Moralis -admin -cli deploy, and then it will ask you for your Moralis API key and eventually the API secret. So you need an account at Moralis, which is free, of course. So let's go to admin.moralis.io and you can sign up. But if you already have an account, you need to have a server, and you can create that on whatever network you want. When you have a server, click on view details, and then you need to get your CLI API key. Paste that here, and then your CLI API secret. Paste that here. And now we'll say following servers were found, and my name was just called AAA. So I'm going to choose that one. And now you can see that the site is available at this URL. So I'm going to copy that and visit that here in the browser. Now you can see we got our index.html file. But this also means that we can also get to our artwork.png, because we can just put /artwork.png. And here's that. So that means that we can use this now as the image URL for NFT number 0. And now I'm going to clone this and do the same for the image. It's going to be called 1.json because the photo was ID number 1. And this is beautiful, let's see here, Kungsholmen photo. Beautiful photo of Kungsholmen, Stockholm, Sweden. And this URL is going to be, let's see here, photo.jpg. And I'm also going to do something here. Let's see, where is the metadata? Here's the metadata. I'm also going to add external URL here because I need to give some attribution to the photographer in question. Here, antonmartinson.com, if you want to check out his photos. They're pretty cool, I would say. I'm not biased, but you know. So I have the URL there, photo.jpg. Yes. Okay. That is everything we need. So now, if I deploy this again, so I do the same thing again. Let's see, yes, I can do that again. I need to enter the keys again. I guess there is some sort of command to make this easier. We're not going to do that many times. What server do you want to connect to? 0. Okay, so now I can take this URL again and I can go /0, or let's see here, /0.json, right? Yes. All right, we have /0.json. And then we have /, and there you see you have the artwork.png. And then we can also do 1.json, and then we get the other one, photo.jpg. And both of these links should work. There we can get the photo. It isn't high res because I just copied it off the website. I didn't ask for the original, but there we go. That works for this, okay? Not gonna sell for a lot, but anyway. The last thing we need to do here is we need to change these names because there is a specific schema to ERC 1155 standard, and we can read that in the actual EIP. We go to metadata, metadata. We can see here that the specification for the EIP standard is that the string format of the substituted hexadecimal ID must be lowercase, alphanumeric, with no 0x prefix. The string format of substituted hexadecimal ID must be leading 0 padded to 64 hex characters length if necessary. That means if you have token ID, what did they have as an example here? 314592, that needs to be converted to hexadecimal and then padded, as it's called, up to 64 digits. And if our number is just 0, our NFT ID is just 0, that means that this needs to be just 64 zeros. So here I have 8, and then I need to have 8 of these. 2, 3, 4, 5, 6, 7, 8. So this would be 64 zeros. I need to put these after each other and then name the file that. Because everyone who queries an ERC1155 token, they are querying using this specific schema. So and this specific standard. So I need to rename this to that. And this, that's ID number 1. I need to rename to all of those zeros, but then a 1 at the end. So you see, this is ID 0, this is ID 1. It is a 64-digit padded hexadecimal number. But this is just 1 and 2. Those are same in decimal as in hexadecimal. So that is now everything we need to do. We just need to save that and once again publish that to the Moralis server. So I'm going to copy this again. And now this is hosted on our website. Now we can deploy our smart contract. So let's go back to our smart contract. And now I'm going to fill in this URL right here. So we're going to copy the URL that we got from Moralis, where our stuff is hosted. We're going to put that in the constructor of the ERC1155 contract. And then at the end, so this is just the base URL, right? Then we, in order to get to the actual NFT JSON files, we do slash followed by the token ID, which we show as, come on, there we go, as these curly brackets, followed by ID inside of it. You can see this. There we go. Dot JSON. Okay, so this is how we provide the URL to an ERC1155 contract. Then what Opensea will do, and as it says in the EIP specification, we can read it here. The URI value allows for ID substitution by clients. If the string ID exists in any URI, clients must replace this with the actual token ID in hexadecimal form. This allows for a large number of tokens to use the same on-chain string by defining a URI once for that large number of tokens. So this is to save space in the blockchain in reality, because now we just need to provide the URI at one place in the contract, and then the client can replace the ID with the correct ID. So if they're looking for ID 0, they put in 0, padded by 64 decimals, 2 64 decimals, and then they enter that URL and find the metadata. So now we're ready to deploy this contract. And of course, we want to deploy it on the testnet, on a live network, not just on the virtual machine. If we deploy it on the Rinkeby test network on Ethereum, we can actually view it on the test site of Opensea. So let's do that. And to do that, we need to, first of all, get some Rinkeby testnet ETH into our account. So you need to have MetaMask, of course, and then you need to open that up. And you need to select the Rinkeby test network from here. And then copy your account ID. And then try to find a Rinkeby faucet. And that's not very easy, actually, to do. If you Google for Rinkeby faucet, the one that actually works is this one. And what you need to do here is that you need to post a post on social network like Twitter. You can see here, to request funds via Twitter, make a tweet with the Ethereum address pasted into the contents. Copy paste the tweet's URL into the above input text box and fire away. So you need to tweet something like this, requesting faucet funds into, and then paste your address here and then tweet that. And then you take the link to that tweet, paste it here, and click Give Me Ether. Then you can delete the tweet after that. But they need to do that in order to guard themselves from bots just taking all the Ether. So unfortunately, that's what you need to do in order to get testnet, Ropsten, Ether. But I already have some, so I'm not going to do that in this video here. But once you have that, you're going to go back to Remix, click Injected Web3 here in the Deploy tab and the environment. This will ask you to connect your MetaMask account. Click Next, Connect, and make sure once again that you have Rinkeby selected. It says here Rinkeby number 4 network. Now we can deploy this. So let's go ahead and make sure you have the contract selected here. Click Deploy. Then you'll have to confirm the transaction. And it will take a few seconds for this to actually deploy. There we go. And now this is actually deployed on the Rinkeby test network, and we can take the transaction hash and we can go to ropsten.etherscan.io and paste this transaction hash into here. And let's see here. No, Rinkeby.etherscan, not Ropsten. Paste this transaction hash in here, search, and here we find our contract. This is our NFT contract, okay? And now we copy this contract address, and now we're going to check this out on Opensea, okay? We want to go to, let's see here, opensea.io/getlisted. Let me turn off my dark mode thing here so that you can see it better. It's opensea.io/getlisted, and here you can see get listed on Opensea. What phase is your project in? We are live on a testnet, okay? And then you get to this, enter your contract address. You need to make sure you select Rinkeby, paste your ERC721 or ERC1155 contract address. So that's what we're going to do. Then we're going to submit. And here we have our 2 NFTs on Opensea. So we see Philip's artwork is here. And we also have more from this collection. We have our photo. And here you can see the description is the artwork of a solidity developer. We have the Kungsholmen photo. And here we can see that we have a beautiful picture. We have details. Let's see here. Beautiful photo of Kungsholmen, Stockholm, Sweden. And the image. Let's see if, where is our, seems like it didn't pick up our website URL, but let's see if it can pick it up. Sometimes I've noticed that they're a bit slow on picking up NFT metadata, so you might have to click on this refresh metadata button for it to work, and then you wait a few minutes and then you refresh the page, because sometimes for me the image doesn't show up until I do that. But let's see if I actually put in it correctly. External URL, I think that was the correct format, but okay, never mind. So now when you have this, the only thing that is left to launch these NFTs is just to, instead of deploying it to the testnet, you deploy it, you select the mainnet from your MetaMask account, okay? And you deploy it through injected Web3, but to the main network. And then when you list on Opensea, you just click live on the mainnet instead, and you list it through here. It's the same process, but it's on the mainnet. And then you can put this up for a listing, since you are indeed the owner. And in order to be identified as the owner of this NFT, you can go to your account here and click sign in, and you will sign in using the same MetaMask account as you used to deploy. And then you can see I have some other test NFTs here. If you go to these NFTs, you can actually click sell here. And now it is of course sold as a testnet NFT, but it works exactly the same on mainnet. So that's the difference, right? And you put how many you want to sell, and you can also bundle it with other items. Price per item, okay. Total price, you can schedule it, and some other options here. And then you can post your listing. I'm not going to do that because it's only on the testnet, but I wish you the best of luck with selling your NFTs on the actual mainnet. Feel free to leave comments when you've posted your NFTs. I would love to see them down below. So post links to your NFTs that you actually have deployed down in the comment section. I would love to see those. And now when we had this, I thought we would also go ahead and create an NFT dashboard that we as an owner can use in order to see who the owner of our NFTs are, maybe use to mint new NFTs from a user interface, to burn NFTs, to see some stats about our NFTs, just to manage. I mean, if this is our business, we want an interface to be able to manage this and see sort of the progress of our NFTs. So that's what we're going to do, and we're going to use Moralis in order to do that a lot quicker, a lot easier than what it would have been otherwise. But in order to do this, we need to start a new, web app project, right? We're going to use simple HTML, JavaScript, and some CSS libraries in order to make this quick. But in order to do this, we need to open up our editor, of course. I'm going to use Visual Studio Code, and yeah, just create a new folder. I have this folder here called NFT Dashboard, and here is where we're going to start to get to work. And we can start by getting the boilerplate code that we're going to use for Moralis. So it just contains the most important init scripts and some Web3 libraries, Bootstrap libraries. And I've left a link to that below. It's this sign-in boilerplate that I'm going to use. And you can clone this, or you can just copy the contents of the file. We're actually only going to use the index.html file, so I'm going to copy that into an index.html file here. And this contains web3.js, it contains jQuery, it contains moralis.js, and Bootstrap, JS library, Bootstrap CSS library, and this we can remove, style.css, we don't have it. And then it contains a basic body with some Bootstrap structure, so it has the Jumbotron and the container, and then h1 as welcome, and then a button that lets you sign in with MetaMask. And then it links to a script called main.js, which we can create here as well, but I'm not going to use the one from the boilerplate. I should actually update that so it's slightly better. The first thing that we're going to do in our main.js file is to initiate Moralis. So Moralis.initialize, and here we're going to put our app ID, we're going to get in a second, and then we're going to do Moralis.server URL, and here we're going to input our server URL, which we're also going to get in a minute. And then finally what we need to do is that we need to attach this sign in button. Well, first I can show you what this looks like. So you need to open up this index.html file, but you cannot do it just like opening up the HTML file in your browser. You need to host it on a local web server. And in Visual Studio Code, you can install a plugin called Live Server, this one right here. And that allows you to right click on this one and where is it? There, open with Live Server. And that will fire up a small web server, and you will open up the file through there. So here I open it through localhost, and that's what you want to have. You don't want to have just the file path up here. You want to have an IP address or localhost, because otherwise MetaMask won't work. So let me remove my dark theme here. So this is what it looks like. Pretty basic for now, but it will do the job. And when we click this, we want MetaMask to open up, and we want to sign in, and then we want to fetch the NFTs for the specific contract that we created. And then we're going to build like mint functionality, burn functionality, and just some stats from Moralis. So first what we need to do is to fix this login button. And to do that, we need to check if the user currently is signed in. So let me first create a function here, an async function called initialize app. And here, we're going to first fetch the current user in order to check if the user is logged in or not. And we get that from moralis.user.current. And then we check if this exists or not. Because if current user doesn't exist, that means we need to sign in. But if it does exist, we can continue. Okay? And so how do we sign in our user? Well, we use Moralis.web3.authenticate. And this is how we authenticate using MetaMask. You can also authenticate using username and password if you want, but this is for using MetaMask, which we want. And then we can set current user to this, and this is actually returns a promise, so we need to set a wait here and set current user equal to this, because we're going to use that object later on. And now we actually need to get our credentials from Moralis. So we're going to go to Moralis admin, we're going to create a server, and then we're going to get our credentials here, because then we can start testing this out in our browser. That's how quick this is. So we're going to go to admin.moralis.io to the admin panel, and you need to have an account, as I said before. And we're going to go to servers and then create a new server. And you want to select testnet server. I'm going to name this NFT Dashboard 2.0. I already have one here, but that's for me when I was testing. So I'm going to do it from scratch with you guys. I also don't know why I'm wearing the headphones, so I should take those off. Testnet, and we need to select Rinkeby because that's where we deployed our token. So click add instance, and now it will create our instance. It can take a few minutes for that to create, but when that is done, we can get our app ID and our server URL. So app ID goes here and server URL goes here. So now it's created. It took about a minute or so, and I want to click on view details in order to get the configuration or the details. So we want the application ID, copy that, put that in there. And then we want the server URL, which is this, copy that into here. And now that we have that, we can actually go ahead and test this function. What we need to do first is I'm gonna alert here that the user is signed in. And we also have to, let's see here. This should be run whenever we press the sign in button, I guess. Well, for this, we actually don't need the sign in button. We'll run this when you visit the site. So let's remove the sign in button actually. And we'll just run this whenever we visit that page, because if we're signed in, then we don't have to do anything. It will automatically initialize this, okay? And otherwise, it will prompt MetaMask, sign us in. So let's try this out in our browser. And we'll refresh this. And now maybe I'm already signed in. I don't know. Oh no. Server URL is not the function. What did we do wrong? Oh yeah, it's not a function. It's moralis.server URL is equal to. My bad. Try this again. Current user is not a function. Current. All of these typos. Let's see now. Now when I refresh, you see I get this. Signature request. Sign in. Sign. And then I get user signed in. And that means that whenever I do this now, it will create a user in my user database. So if I go here in Moralis admin, click on dashboard, it will open up the server dashboard for this specific server. And you can see that in the user table, let me make this bigger. In the user table, I have one row with the address that I used to sign in with. You can see accounts, here is an array with this address. And it will also give me directly, this will update, you know, in just seconds, ETH NFT owners. And you can see here that this address that I signed in with, it owns NFTs, so it will automatically pull those into the database. And you can see that it is ERC 1155, also have 1721, because as you saw on Opensea, this address held multiple NFTs, but we're gonna only work with the NFTs that we deployed, which is actually this address because I recognize it, 8260 or C82. So it is this NFT and this NFT. I own two of them. It also pulls in things like NFT transfers, ETH NFT transfers. And here you can see the different transfers that have been made with this address and the NFTs that I hold. You can see that we've done some mint function calls, which will call the transfer function for these different IDs. It will also pull in things like ETH token balance, and here you can see that this account holds link tokens, and all of this is queryable from the front end. But we're going to work primarily with the NFT holdings of this address. But there are other ways of working with NFTs with Moralis, and that is by using the Web3 API, which we're going to do quite a lot of. So we're going to use, for example, some of these NFT functions here. Retrieve the unique NFTs inside a given contract, because we're looking to, as an admin, pull in all of the NFTs that is within our contract. And this can be done from within both the REST API that we show here, but also from the Moralis JavaScript SDK that we have in our frontend. I'm going to show you how we do that. And that's really the first step here, now that we are signed in, is to start pulling in the different NFTs that we want to manage here in our app. And all the different SDK functions that are available can be found in our documentation, docs.moralis.io, and click on Web3 API under server. And here you can check out token, the token API. And here we'll look for the function that we want, which is, I think it's, yeah, get all token IDs for a specific address of a token contract. Yes. So this will give us the NFTs of a specific NFT contract. So this is what we're going to use in our code. So when the app has initialized, we don't have to alert anymore. But what we're going to do is that we're going to call a function to get all NFTs. So we're going to create a function that is like, or we can call Moralis directly, actually, Moralis.web3 API. So here is how you access the Web3 API. .token get all token IDs, and that's what we saw right here. Yep, and it takes some options, which is the address and the chain. And the address is the token contract address, and the chain for us is Rinkeby. Okay, we're gonna pass these options in here, and then finally we need to figure out the address of our deployed contract, and that we can find, for example, at Opensea. Because in the URL here, you can see that it says assets / and then there's an address. You can also find it in your wallet history, of course, when you deploy the contract. But here is one place where you can find it. So we need to have that in here, a token address. And then we can console log our NFTs. And then we can see how we're gonna draw them up in our interface. Okay, so save that, and I'm going back to the app, and already you can see that it has run this new code, and we do have some new data here. So this was the result that we console logged from the NFT call results. We have token ID 0, token ID 1, or rather, these are just array numbers. Here you have token ID 1, here you have it token ID 0. You can see that, okay, there are 6 of these token ID 1s. There are 4 of these token ID 0s. You can see the token address. You can see that the token URI, which has automatically, according to the specification, filled in with the right ID. So this is 0.json, and this one is 1.json. Maybe when you're watching this video, you already would have gotten the metadata included here. We're working on including the metadata automatically, so you don't have to fetch the token URI yourself. But currently we're working on this, so it doesn't work yet. But soon you will just have to call this function. You will have all the metadata for the different token IDs. But for now, we have to fetch the token ID from the token URI. But keep an eye on the documentation. Maybe this already exists, and keep an eye on the object in here, because maybe the metadata is already included when you call this, or there might be another function in the API to get the metadata. But for now, we have to get that ourselves. And that maybe is the next step before we draw them here, because we want to draw them with the images. So we want to fetch the image URL from the JSON file that is the token URI. So let's do that. And this will be a little bit tricky, because we have to loop through each of the NFTs in this response, all the metadata, and populate the object with the metadata, so that we have the object.metadata including all of the images and title and description and so on. So we're going to create a new function, and we're going to call this fetch NFT metadata. and it will take the NFTs as an argument. And it's not going to be an async. This function is not going to be async. At least I think so. So we know we have to loop through all of the NFTs. So we just need to fetch for each NFT. So we're going to create a for loop. And I'm going to call this I. And then I'm going to change this to NFTs.length. These I. So now we have our NFT element here. And we can call this NFT. Oh, that is one specific instance of the NFT, so that would be NFT 0 or NFT 1. And then let's also define, well, let's not make this const because we're gonna modify that. Also, let's create the NFT ID, which is nft.token_ID, because we need to use that. And then finally, we need to make a call here and fetch the actual metadata. And here, depending on where you hosted your metadata, I've hosted mine on Moralis, and unfortunately we can't make a direct fetch call to there due to the course rules. So we have to create a function in our cloud function. So we have to create a cloud function in Moralis that fetches the metadata for us from the backend and then passes that onto us here. So here we're actually going to call, let me demonstrate that here. Here we're going to call Moralis cloud function, which in turn will call our static JSON file. It will return that static JSON file to the cloud function, which then will return it to us. Okay. Here we're going to fetch a cloud function URL, and it will be something / function name, and then we'll attach the token ID here. Okay. It'll look something like that. But first we need to create this Moralis cloud function that returns our JSON file for us. And to do that, we go to the Moralis dashboard, the server dashboard here, and we go to cloud functions, and here is where we can build our cloud function. And all of this is available in our docs, but the way you define a cloud function is by saying moralis.cloud.define, and then the name of the cloud function, and we're going to call it get NFT. Yeah, and this will be an async function. It takes as an input argument a request object, and then we define the function here like so, and here is where we write our function code. First we're going to start by getting the NFT ID. So the NFT ID will be in request.params.nft ID. So we will have to pass this in through the request object as NFT ID. And now you remember that we're going to call here, we're going to make a call to a moralis.cloud.http request. And here we need to specify the URL we want to call. And the URL looked something like this. You'll have your own unique URL. But as you know, this is the metadata URL. And then we had a bunch of zeros followed by the ID. And we can't hard code that here because we don't know in the future how many NFTs we want. So we need to create this. We need to take our NFT ID, which is in decimal, and create that into a padded hex string that is 64 numbers long, and then append that to the end of this URL here, and then have, you know, .json. Okay, that's what we're gonna do. We're gonna do this, and here we need to include the padded hex number. That will give us the right URL to call to get the metadata. And how do we create this padded hex? Well, let me show you. We're going to start by converting our NFT ID into a hex ID. We can call it hex ID. And we do that by first parsing it as an integer, because it is a string when it comes in here. So NFT ID needs to be an integer. And then we're going to call toString base 16. So that will create a hex string for us. Because hex is of course base 16, that's why it's called hexadecimal. Then we can create padded hex, because this needs to be padded to 64 digits. And to do that, we first will write 64 zeros here as a string. There is 8 zeros, and then I need to do that 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. Let me make this a bit bigger for you, by the way. And now we're going to append to this string the hex ID. And now what we want to do, because now this will be longer than 64 digits, we want to cut off the remaining digits here, as many as we need in order to make the remaining here 64 digits long. And that can be done by the slice command minus 64. That will take the 64 most right digits and give us those back. And that will give us the padded hex as we want it. And after that, we can call this cloud function right here with the padded hex. Like so. And then when we get the response back, we'll get it as a function here, HTTP response. And here we're going to return HTTP response dot text. That will give us the value back as a text. And we can also specify here if you want an error handling function. But we're not going to do any error handling now. Let's hope this works. If it doesn't work, we can add that. And something that can be good to know is that you can define a logger here. If you need to console log things, if it doesn't work, you can do a logger, moralis.cloud.getLogger. And this you can then use like this, logger.info, for example, padded hex. If you want to see it in your console, we can check this out, because when I save this, let's just see so we don't get any errors here. You will see an error if there's any compilation errors here, but then if there's a runtime error, you'll get it later. The log of this will be seen here in the dashboard or the server dashboard, and then on logs. Here you will see your cloud function being called. So now, how do we call a cloud function from our application? Well, we have that in our docs actually. So if we go to cloud code and then cloud functions, and then calling via REST API. It's on here on the right. We call it by using our full Moralis server URL. We add /functions, then the cloud function name, then our application ID as a query parameter, and then optional our cloud function query parameters, which is the NFT ID in this case. So I'm going to copy this, or no, I'm not going to copy that. But we're going to go to our fetch NFT metadata here, and here I'm going to fetch our server URL /functions, as it said, then / our cloud function name, which was something that I forgot, get NFT, and then query parameter, so question mark, what was it going to be called? Underscore application ID is equal to our application ID, which we have here, and then another query param, so the ampersand, and then we call this NFT ID, I think. That's going to be equal to our let's not do that, equal to plus our NFT ID. I think that's it, or we just call it ID. And let's just double check so that we actually called it NFT ID like this, and the same capitalization and everything in our cloud function. We called it NFT ID. Is that what we're going to pass in? And then let's see the result that we get from this. Dot then, let's just say result, and let's console log it. Okay, Let's try that. And when are we going to call this fetch metadata? Let's call it here. Fetch NFT metadata with NFTs as the argument. And then we console log here. Yeah, let's see if we get the metadata back. Let's refresh. And it didn't console log anything. Let's try to figure out what happened here. First of all, did we get any error in our logs? Let's refresh. Doesn't even seem like it ran. So let's see here. Sources. Let's see if this actually ran. It did run here. Did we run this as well? We never run the fetch call. What's going on? Do we get an error? No. That is odd. Maybe I must have made some weird error here when passing this in. NFTs empty. Of course, we're gonna pass in nfts.result. My bad. Let's try this now. There we go. Look at that. We got 2 responses back. It contains a body. Yeah, we need to parse this. So we're gonna console log res.json as a function. That will parse the body as JSON. Oh yeah, that is a promise, of course. We need to do this. And then res console log. So maybe we need to put that there. Let's see. We console log res. Let's see. Now it's empty. Then we can try to check the logs. So this gets passed in correctly. You see that it console logs the ID, which looks correct. But it says result undefined. Here it was correct. No, that was get all token IDs. Let's see here. Maybe we have to return this. Yeah, we have to return this promise. Let's save that and let's wait for it to reboot quickly. And now we can try again. All right, so now if we refresh this again, we get this. And what we have here is basically an actual object with a result property that then has a string. And so this string, we want to parse this into JSON, okay? We want to parse res.data into JSON. So the json.parse, res.data. And let's try to console log this instead. Let's see. It was result, not data. Res.result. There we go. So now you see we have the metadata, the real metadata for the 2 token IDs. Now what we need to do is that we need to take this result and put it back in the NFT object so that we can use it later on down here. So that's what I'm going to do after I've done this parse here. I'm going to take this result and I'm going to set nft.metadata equal to this data. And then that's all we need to do actually. For now, we can remove this console log, and instead we're going to try to return this somehow. And I mean, we can't put return here because this would then be run inside every for loop. Instead, we need to collect this into one promise, and when that's resolved, we can return an array of those results. So we're going to do an array of promises. So I'm going to create that up here, create an empty array, and then for each one of these for loops, let's see here, is it enough to push this promise? Let's see, can I do this? Promises.push fetch, and then when these for loops are over, we're gonna do promise.all promises. I'm gonna return that. So what this does is that it waits for all of the promises in the array to complete, and then it sends back all of the results. Why? Press. There we go. Put the wrong label there. So we return that, and then we'll get it back here. So let but let's see. We're not actually interested in getting the promises, are we? We're interested in actually getting the NFTs. So what if we do here.then, and we return the, don't need it actually. We return the NFT, which we just set the metadata of here. And then we do that, yes. So let's call it NFT with metadata, and it's going to be equal to await that, and then we're going to console log NFT with metadata, and hopefully that's going to include the entire NFT object and all of the metadata. Let's see, promises push, but then it's not a function. Or is there some things up here? There we go, the parentheses was in the wrong place. We need to include this as well inside of the fetch call. There we go. Do NFTs, metadata, boom. There you see, now we have the full object here. So now we can start to actually draw these out on the screen, because now we have all of the data we need. All right, so this NFT with metadata, we can use this and actually start putting something on the screen. So let's create another function for this. This will be function draw inventory or render inventory. Okay, it's going to render all of the NFTs. We can pass in NFTs in here. And here also we're going to have a for loop, right? Because we need to loop through every NFT. And I want them to look like cards, like you would see on some NFT marketplace or whatever. NFT. All right, so now we're in the same position we were up here. What we're going to do up here in here is that we're going to create these cards. Let me show you what I mean. Bootstrap Cards. So we're going to use these. They're going to look like this. And they will be nicely positioned in a grid. And we can have an image up here, a title, which we have a name of the NFT and then a description. And then we can have some action buttons down here. And you create them like this. Card image top, card body. And since we already have Bootstrap imported, we can pretty easily accomplish this design without having to do any design work ourselves. We just need to create the right layout. So what we're going to do for each one of these, we're going to create an HTML string. And here we need to use these special quotation marks that are like sideways. I don't know what you call them. And because this will build you a multi-line string. Then we're going to copy this card thing in here. And we're going to replace the content with the content from our NFT. So for example, the title will be, you use this $sign and then curly brackets to insert data. NFT dot, was it name? What did we call it? Metadata dot name. And then description. We have here. It will be metadata dot description, I think. Yes. And then button we can do later. Card image. So that what we need to fill in here is the source of the image. And that's going to be metadata dot image. Actually image, that will give us a URL to the image. And that's it. Let me do this. That's it. All we need to do now is to add this to our index.html file. And here we only have a container. What we need in here is a row and then some columns, and then we can start adding these cards. So let's create a row here. Div class row, that's a special Bootstrap class, and we're gonna name this app, this row. And then we need to add this card to a column element. So we're gonna create a column element. Document.create element. This is gonna be a div. And we're gonna set that column.class name gonna be equal to column and column dash md dash 3. That's a medium column of width 3. That means it will fit 4 columns on each row. Each row in Bootstrap is divided into 12 columns. And this column will take up 3 units. And then finally, column.innerHTML will be equal to our HTML string. All right. Now all that's left is to add this column to our actual parent element, which is the row. So we're going to define that up here. The parent is equal to document.getElement by ID. And we named it app. And then down here we can go parent.append child, which will add our column element, which now contains this HTML inside it. We'll add that to the row element right here. And it will do that for each NFT since we're looping this through here. Let's see if we got it working on the first try. No. Well, we need to call this function. Render inventory, we're going to call that here with the NFT with metadata as the input. Save. There we go. Let me zoom out here. Oops. Something is wrong with the layout here. Card. We just have, let's see, we have column. This column is inside the other column. What's going on here? Super weird. What did I screw up? But I mean, even though we screwed it up, it looks pretty cool anyway. It's fascinating how quick you can get this to work. Ah, maybe this width thing is screwing it up. Yeah, let's remove that width thing. I don't like that. I don't know why they included that. Let's stick with the normal style. There we go. Now the width is corresponding to the column size instead. So maybe we could make it a bit bigger. So we'll make it column size 4. There we go. Looks better. Now the aspect ratio of these images are not the same. So unfortunately the cards will not be equal height here. But if you chose better images that are more similar, you would probably have equal aspect ratios of your images. But now we got the image, we got the title, the description for both of them. And now if we mint more NFTs, it would automatically loop through them, get all the metadata, print them out here. So this is a great start to the NFT dashboard. Now, what's left, if we want to bring in some more stats here, is to get some more information about the ownership. How many people own these NFTs? How many are there, like the current supply? and maybe even what the owner addresses are. And we can add that under here. We just need to implement another API call to Moralis and get the owners and get all of that. So we're going to do that. And then after that, we're going to build a mint page where we can go in and we can mint new NFTs. We can enter the address, enter the amounts, where we want to mint, which token ID, and so on. And we're going to connect that to the button here. But first, let's add information about the owners. And I'm going to share with you the endpoint or the function that we're going to use. So let me go to the docs page. And we're going to check out the Web3 API. Let's see, is it token? Yes. And we're going to use here the get token ID owners. Get token ID metadata, get token ID owners. This one. This is going to give us information about the owners. How many people owns it, and the number of tokens in circulation and so on. We're going to use this one and get that information. And we're going to do it before we return this NFT here. We're going to do it in here. We're going to take the result once again, and we're going to make an API call here and return moralis.web3api.token.get token ID owners, and we can get the options here. That's in the options. We need the address once again. Where did we have that? Here. Maybe you should add that here. Let's maybe create a const contract address equal to that. And then we need to specify the token ID, which is just ID from here. And then finally chain is Rinkeby. All right, we got that. Did we? Yeah, we put contract address there, perfect. And what this will give us is an array of owners. We can console log this here. No. We will get it here. Result. We can try to console log the result because this will give us an array of owners, which we then also going to append into the NFT object. So we get everything in one nice object. So get token ID owners for token ID, and we do this for it. All right, let's check this out. So now we get some error because it can't read the metadata because it didn't return the correct thing. But now we can see how we console logged here, and that's the result here. And we can see that this NFT, which is token ID 1, has 2 as amount, which is the total supply of tokens. And we have 1 owner here. And then the second token is here. And here we have token ID 0. And this is the owner right here. And if we were to have multiple owners, we would get this array would extend with multiple objects for each NFT. And now we can mint more in Remix if you want to mint more in Remix. To see that, let's do that, because actually I had to redeploy my NFT contract because I managed to delete my Moralis server where the metadata was hosted, so I had to redeploy that. So that's why I have fewer owners here now. But let's go into Remix and actually mint some to some other address. So I'm going to copy another address I have here. Copy that. Then I'm going to mint that address, token ID 1, and I'm going to mint 2, or let's just mint 1. And from that, yes. No, that is mint. Okay, transact. And then this is gonna take some time before it gets included. There we go. And then it also takes some time for this to be confirmed enough to be included in the NFT API. So it will have to pass a few blocks before it gets included in the API. But sooner or later, we will get it included here in our result, meaning it will be another another owner of token ID 1. So this was 0. Here in this array, there will be another object with the other owner. And now if we refresh this page, you'll see that we now have the actual new owner info. So we did mint ID ID 1, and as you can see here, this will be ID 1. So here we have an ID 1, and we now have 2 owners. Previously we only had 1. So this result will be an array with the individual owners. We have token address that will be the same, owner of. This one will be different. Here, this one starts with B5. This one starts with 34. So here is how we see the individual owners. And just like with the NFT data, we want to aggregate this in a nice way into the actual NFT object, which we then use to render. So what I was thinking is that we're going to get the owner info into the NFT object, because then we can display owner info. And I believe we already have in our previous data, we already have the total number of NFTs that are minted. We can use that and display that into our little cards here. So here's where we left off. We console log the result here, but instead of console logging it, we're going to modify the NFT object again. What I'm going to set is that nft.owners will be equal to an empty array. Okay, and here's where we're going to loop through the result that we got, and we're going to add them into the NFT. So we're going to do res.results.forEach. So we're going to loop through all this. Oops. There we go. And we're going to push this into the owner's array. So we're going to push element.owner_of. So for each NFT that we're looping through, we're going to push this owner_of address for each token into the NFT, so that we get an array of the addresses that own a specific NFT. After this, we're going to return NFT. Let's see if this is correct. It seems like it. We're rendering now again. So let's check if we can render. For example, we're going to add another card text. And we're going to say owners, or number of owners. Going to be equal to nft.owners.length. Let's try that. There we go. Number of owners 1, number of owners 2. Now we should also be able to get the total number of NFTs. So let me console log the full object here. Console log NFT just to see. I don't remember what the amount. There we go. So we can also add, maybe add that before the number of owners. We'll add tokens. What do you call this? Tokens in circulation. And NFT dot, what was it? Amount. Or we could just say amount. There we go. Amount 1, number of owners 1. And here we have amount 3, number of owners 2. So now So now we're pretty much done with the basic, well, the getting of information. And we got the amount, we got the number of owners. What I want to do now is to provide mint functionality so that we can mint these NFTs from an actual interface. And to do that, we need another button here, right? For each of the NFTs that will go to a new page. So we need a second button here. Although this button is not used. So we'll use this for mint. And what is the link going to be? Well, we need to specify, we need to create a new HTML file for that content. And I'm going to call it mint.html. And here we also need to pass in the NFT ID that we want to mint. Because if I click on this button, I want to mint the NFT with this ID. If I click this button, I want to mint the NFT with this ID. Okay? So I'm going to pass in that as a query parameter. So I'm going to put question mark, then the name of the query parameter, which then will be NFT ID. That's going to be equal to NFT.id. That's the token ID. All right. We'll save that. And now we need to build this mint.html file, read in this parameter, and have some sort of form that we then use to mint. Okay. So let's create this new file, mint.html. And we do need a lot of the same stuff as in index.html. So I'm going to copy all of this and then we'll remove what we end up not using. So we'll use the same libraries. We need Moralis, we need Bootstrap. We're going to have the same Jumbotron. Maybe we should not call this welcome. Maybe we should call it something else. Like NFT manager. Okay, we'll call it that there. I'll call it that here as well. We're going to have the container. We're going to have the app. And we're going to have a file. We're not going to have main.js. Let's have mint.js so that we have specific logic for the mint page. And in the mint.js, well, let's wait with that. Let's start with actually doing the layout here. So in the app div, I want to create an actual form. So I want to have input fields where I can input how many I want to mint and to what address I want to mint them and so on. So I'm gonna create a div in here, which will contain an input field, which will have, let's say, ID. This will be the token ID input. And this will be pre-filled with the data that we got from the URL. But if we want to enter the token ID manually, we can do that too. Value, maybe we don't have to provide value, but it's going to be empty. Type is number. And then I also want a label before this. So label is going to be token ID. And then I'll do the same for the other info that we need. We also need amount, how many we want to mint. Token amount, or maybe just amount input. We need the same for, and this is also number. We need the same for address, so where we want to mint these tokens. Address input, this will be type text because it's not a decimal number. And then finally, we need a button to actually send this away. So this is gonna have, first of all, some classes because we want it to look like a Bootstrap button. So btn-primary. We're gonna say mint, and we should also give it an ID, which is submit mint. Okay, that's it for the HTML. We have mint.js, which we're gonna start building. What we need to do, we need to grab the NFT ID from the query parameter, fill it in as the token ID, pre-fill that, and then we need to let the user input these two. And then when they press the button, we need an event listener, which we're going to use in order to call the contract method, call the mint function in our contract, and then wait for the response and display some sort of message when it's done. All right. So let's start with that in the mint.js function, or if you want to check this out, we can open this up in our browser. So if we should be able to, let's see, click here and go to the mint page. Here we go. All right, so that wasn't too pretty. Should we style that first? But we did provide div, so let's see what we did wrong. But yeah, we need columns as well. So we have the row. We also need div class call dash md12. So this is going to be full size column, and we'll put everything there. Okay, save that. There we go. So that looks a little bit better. Can be styled to look more beautiful, but that's okay for now. Now let's work on the logic in mint.js. So we do need the same Moralis, initialize, and contract address, all of that stuff here. And we need to have an init function that will make sure that the user is logged in and so on. Function init. So what we're going to do is we're going to grab, did we do this in our previous init function? Could we copy this? Yes, we can copy this. Have this here. But if the user is not logged in, let's just redirect them back to the index page. Because there we have the login function now. If it's not logged in, then they go back to the index.html. Now, let's get the NFT ID first of all. We can pre-populate that. So first, we'll get the URL params object, which is a special special class in JavaScript where we get the search parameters, the query parameters. So we input window location.search. That will give us the full string of question mark equals and all that stuff. And then we can extract the NFT ID using URL params.get for NFT ID. I think we call it that. NFT ID into the same thing here. All right, and we can console log that. If we want NFT ID, we can check so we got the right thing. Now, if we refresh this, it didn't remove this. We don't need that. Save. Did not console log. Oh, I know why. We don't call the init function. Let's call that. That will help. There we go. 1. So if I change up here to 2, we'll say 2. All right. Let's change back to 1. And let's continue. So when we have that, we're ready to actually call. Well, we're going to get the other info as well. So before we can make the call to the contract, we need to get the other info. So we need to get the address info and the amount info. We're going to extract that as well. And we should also set the value that we got from the URL. We should set that here. So we're going to do document.getElement by ID. And the ID we set was token ID input, I think. Yep. And we're going to set the value to NFT ID. All right. And that's all we need to do in the init function. There we go. And now we can increase it if we want, but it will default to whatever we put up here. The rest of the stuff should happen when we press the button. So let's create another function that's called mint. Because the other information, as the address and the amount, is not available when we just load the page. It will be available when they click the button, but not before that. Because of course they need to fill it in. And here we can get the token ID. So token ID is going to be equal to document.getElement by ID for token ID input, or did we just call it ID input? No, this was the one we did previously. Yes, we need that one. And here we also need to parse this into an int, because our smart contract expects this to be an integer and not a text, which the value of an input field is automatically in JavaScript. Then we're going to get the address, which we should do the same thing. But this can be a string, and this we called address input. And then we're going to do the same thing for amount. This was amount input. And this should also be an integer. There we go. Now we need to do the actual call to the smart contract. And this we need to use the Web3 library for. And Moralis has the Web3 library built in into the Moralis object, so we can use it through there. And the way we get access to that object is to first of all initialize it. So that we can do in the init function. But we're going to define an empty object up here called Web3 because we're going to use it in all of our functions. And then in our init function, we can set Web3 to await Moralis.web3 with a capital W, important, .enable. Okay? And if this works, we should be able to get the accounts, for example. So let accounts be equal to await web3.eth.get account. So this will give me the current signed in count. So let's just see so this works. Enable of undefined. So I didn't even set it to capital W. There we go. Enable. There we go. So there we got the address, and this is the current signed in MetaMask address. So that works. Good. We could actually pre-populate the address field as well. So we could assume that if I mint, I would probably mint it to myself first and then maybe transfer it. So let's also say that we will do this. We'll set the value of the address input as well to accounts 0, which will be the current signed in MetaMask address. All right, let's see if that works. There we go, address, perfect. Now let's focus back on the mint function and our Web3 call. So what we need first is to define the contract. So it's going to be constant contract equal to new web3.eth.contract. Contract is actually capital C. And here we need to specify the contract ABI, and then we need the contract address, which I think we already have here. Yeah. Boom. And that's it. And we're going to talk about the contract ABI because what the contract ABI is just the specification, the interface of your smart contract. It will tell this JavaScript program, logic, website, which functions are available, what parameters those functions accept, what they return, and so on, so that our code can interact with the smart contract, because it needs to know it needs to know the interface. It's like speaking the same language. So we need to provide that, and we can get that from Remix. Probably, if you're watching this video in a few months' time, there will be a Moralis function for this. So you should check out the documentation. It should be something similar to what we currently have with transfers. Let me show you that. So if I go to docs and then sending ETH tokens NFTs, we have something like this for transferring NFTs. You just set the options. Okay, this is an ERC721 token. The receiver is this. The contract address is this. The token ID is this. And then you do Moralis.transfer. Normally, you would need the ABI for this as well. And you do this Web3 procedure. But we've simplified the transfer to just this. You just need to call a function. You don't need any ABI and so on. This will probably come to the mint function as well. So check out the documentation and look for this. So you can probably just do Moralis.mint and then the options like this. Because that would reduce the time and complexity a lot. But for now, we need to go to Remix and we need to find the ABI, which, let's see where that is. They moved this. So if you go here to Solidity compiler, compilation details, well, you even have a shortcode for it here, ABI, copy. And then we're going to put this into a special file. I'm going to call it abi.js. And here we'll just put const contract ABI is equal to. And then we just paste whatever we copied. It's a long array of different methods, different variables, different events, and so on. and we save that. And now we have to include that as well in our mint.html function, so that we get access to this contract API object. We're going to include that down here before the mint.js function. So we're going to include API.js. All right. So now mint.js, we can here just write contract API, and then we have contract address. That's what we named it, right? Yes. Now we have the contract object defined, we can actually make the actual mint call. Then we go contract dot methods dot mint, and then we input the parameters that this mint function takes, which you can see here. It takes address, account, ID, and amount in that order. So we will provide the address, which we got from here, the token ID, which was next, and then the amount. And then we say .send to send the actual transaction. Now we need to specify from where to send this transaction, from which address. And here we're going to use the account from MetaMask. And you already know how to get that. So const accounts is equal to await web3.eth.get accounts. And then we can use accounts 0 here. And value is the amount of ether that we send to this function. And in this case, it's going to be 0 because it doesn't cost us anything to mint. Gas fees will be on top of that. This is just how much actual ether we want the receiver to get. Now, this will prompt the MetaMask method to come up. If we save this. Wait, did we actually add a... No, we did not. We need to add a on-click event. So on the button, so that when you press the mint button, we actually run the mint function. Get element by ID, submit mint dot on click is equal to mint. That way we'll run the mint function whenever we click the submit mint button. And we did name it. Let's go back to our site, refresh, and make sure our MetaMask is unlocked, which it is. Say I want to mint token ID 1. I want to mint one of them. I click mint. It's here. I misspelled once again. Contract should be capital C. Or is it here? I don't know. Does it correct me, or is I'm writing it wrong? It seems like it's correcting me because I pointed out that we should do capital C. Refresh. Amount 1. Mint. Is something wrong with the address? Invalid address. If we do that, let's see. Contract address is correct. Did I update it? That's the question. So let's console log accounts 0 to make sure that's correct. But maybe I didn't update the contract. That is correct. Let's see if this address is correct. Of course. Need to do dot value. Otherwise, it just return the element. Dot value. There we go. That should do the trick. And the same thing here for address. Dot value. Refresh, amount 1, mint. Now it brings up the MetaMask window and I can sign this. But before I do that, I want to create the actual function that will run whenever this is complete. So we can run .on, which will listen for specific events, .on, and then receipt. So this will run whenever we get the receipt back, which means the transaction has been added to a block. And then we're going to run a function. We can get the receipt into the function, and we can run it console log, or we could alert and mint done. Okay. And let's try this. So you need some testnet, Rinkeby testnet ether, of course. We're going to mint 1 of token ID 1, mint. And let's confirm. And then it will take me a few seconds maybe for this to complete, and then I should get an alert statement. There we go. Now the mint is complete. And if we go back, so this would be a minted to ourselves. So we wouldn't notice it directly here if we go back to index.html. We wouldn't notice it straight away, apart from the fact that amount should increase. So let's see. This was ID 0, right? No, this was ID 1. Okay, so this should increase to 4 because we had 2 previously. But as I said, the transaction needs to not only be in one block, but it needs to be confirmed. So it needs to be in a few blocks, because otherwise the Moralis API cannot know, or rather it would give you transfers that are complete, and then they would get removed because the chain will fork from time to time with just small differences in blocks. So it takes some time before we can say that this transaction is actually confirmed. Just like when you have a wallet, it will take some time before the transaction is actually confirmed. And that's the same thing here. If you're looking to get the pending states of transactions as well, you can utilize the Moralis database for that. There, the transactions would appear instantly, and then they will have a status pending. But in the API, it will take some time for it to actually be confirmed, and then it will be included. So I'll wait for a few minutes, and then I'll refresh this, and we should be able to see that the amount of token ID 1 has increased to 3. And now if we refresh, we can see that it now is 4 amount in total. The number of owners haven't changed because we minted it to our own address, but the number of tokens have changed. So that means our mint call is working. Now, before we wrap up this video, I'm also going to do a transfer page because Moralis has a very nice API for doing transfer. It's just one line of code to do a transfer. You don't need the API or anything. So I'm going to show you how we do that. And it's going to be very similar to how we did the mint page. We're going to do a new mint page, but for transfer. So let's copy this mint.html and instead do transfer.html. This will allow us to send tokens from our address to someone else. And we're gonna do copy mint.js, and we're gonna do transfer.js. And in transfer.html, we have to, we don't need the API, but we do need transfer.js. And in index.html, we need to add another button, or rather that is in main.js. In this right here, we need to add the second button here. Let's see if this is going to work from a UI perspective, and it's going to go to transfer.html, and it's going to send in the NFT ID as well. And let's say that this is, well, it can be primary for now, but we're going to set the name to transfer in the button, the label, and let's see if that works. There we go. It looks good. So I'm mint and transfer, and when we click transfer, we'll get to the transfer page. Now, the transfer page looks exactly the same because we copied it. So we're gonna go to the transfer.html and change here so that this button says transfer. The address should be here, the amount should be here, the token ID should be here. All right. What we should do, however, is to go into transfer.js, and we should change a few things. First of all, we don't need Web3, so this we can keep. We don't need this Web3.enable. We don't need accounts here. We do need this NFT ID, so we're going to set token ID to that. Address input we're not going to set because we want to send it to someone else. We don't want our own address to be the default. We want to send it to someone else. We're going to rename the mint function to transfer. And when we click on, let's call it submit transfer, we're going to call transfer. So we need to update transfer.html so that this button is submit transfer. And then still need to grab the token ID. We need to grab the address. We have the amount we want to transfer. We don't need these things. Here instead, we're going to utilize the Moralis API. And we do have that initiated up here already. So we're going to go to the Moralis docs and we're going to check out sending ETH tokens and NFTs. And we're going to go down to transferring ERC20, ERC 1155. Here we go. That's what we have, ERC 1155. And we can copy this here because we're doing it options and then result Moralis.transfer. Moralis.transfer is all that we need. So first of all, options. Well, here's actually an error in the docs. This should be ERC1155. I'll change that right after this video. Receiver, that will be the address from up here. Contract address, that will be this right here, your contract address. Token ID will be this token ID right here, and amount will be here. That's what we fill in the on the transfer page, and then we call await Moralis.transfer with the options, and then we get the result back. So when we get that back, we can console log the result. Okay, and with that done, we should be able to run this now. Everything should be working because we already set most of it up when we did the mint page. So let's try this out. Go here and we go to the transfer page, and our account that holds the NFT now is this account right here. And I believe we hold 2 NFTs of ID 1 or maybe even 3. So we're gonna send using this account, but we need another account to receive it. So let's say we create a completely new account. Receiver, test receiver, create that, so that we know that we will have a completely new address that doesn't have the token yet, because then we can see that in the dashboard. Maybe, you know, before we actually try the transfer, well, let's try the transfer. I was thinking we should add like your balance to the front of the NFT manager as well. Amount is to do 1. We're going to transfer to this address. Let's try this transfer. We'll bring up MetaMask. We'll do the transfer call. We're going to hit confirm. And once we get the receipt back, the Moralis SDK will print out it in the console, because we said console log the result. There we go. Now we see the block hash, block number where this was included. We see the events, which would be the transfer event, but it's in hexadecimal, so it's a bit hard to see, but this would be the transfer event. And we can see who it was sent to, but this is the contract in this case. So now, once this transfer has gone through, we should be able to see that the number of owners here will increase. But once again, it will take a few blocks to this to be successfully picked up by the API, because we don't want pending transactions to be in the API. What we can do in the meantime is that we can implement your balance, so that we get that as well. So with the current MetaMask account, we can see what the balance is of our address. I just realized that our owners array doesn't really work, because in this result for loop it should be owner underscore off, not owner off. Let's see, maybe is it lowercase o? I think so. There we go. Now it actually works. It actually didn't give us any error here. This number was still correct because it did push one object for each owner, but it was undefined, so it didn't actually show the address. But there we fixed that. We can do this in multiple ways. We can either call a Moralis endpoint and get how many tokens we own, our balance, straight away from the API, or we could, when we loop through these tokens right here, we could just count if the owner is actually our address that is currently authenticated on the website. And I guess the efficiency of that would depend on your applications, how many NFTs you have, and what's faster, looping through the different owners, or just calling one API endpoint per token. I would guess that for most people it would just be better to call the API endpoint. So that's what we're going to do. So we're going to find the API endpoint that we're looking for. Let's see here. So what we're looking at using is this, let's see, address NFT /token address in the account API. And we can try it out here to see so that it is what we're actually looking for. And we're going to use chain Rinkeby, and we're going to input, let's see here, the owner address. So we're going to switch back to our main account, copy that address, and then token address we have here. I'm going to input that as well, and we're going to execute. And here we get back that we own 2 of token ID 1, and we own 0 of token ID, sorry, we own 1 of token ID 0. Okay, so this one is perfect. This one is perfect for what we want to do, but I cannot input the actual token ID here, so I'll have to figure that out somehow, because this endpoint will give me all of the NFTs at once. That really means when we get the NFTs with metadata, what we need to do is we need to do another call here. So let we could do owner data equal to await get owner data, and we'll make another function out of this, and we don't need anything to be passed in here, so let's create this function get owner data, and this should be async function, and here we will make a call to the Moralis API. And this will be account dot, let's see what this is called in the SDK. This was the REST API. Let's see here. Account get NFTs for contract. Or we can copy this actually. We're gonna return this and chain Rinkeby token address. We have that token address. Then we have it up here. Contract address, sorry. And address is gonna be the current signed in user. And you've seen me get this from MetaMask in the past, but since we don't have the Web3 object here initiated, I can also show how you can use Moralis to get this. So you can let accounts be equal to, well, let's see, we need the current user. So should we let's make the current user a global variable here. And then we can use current user here dot get accounts. All right, this will give, you can use this get method to get anything that is in the Moralis database for this user. And accounts is similar to the Web3 accounts array, just an array of all the accounts that this user has. And we're gonna get address accounts 0, because we're gonna get the first address. In this case we only have one, but it could be the case that you do have multiple ones, and you might have to loop through them if you want to get all of the accounts, because in Moralis you can attach multiple addresses to one user. So that should do the trick. We'll return this, but we need to make this a bit prettier, the actual return statement, or what we're returning. So here we'll get result. Because what I'm thinking that I want to return here, but let's actually let's console log result first, because what I want to return is something like, okay, token ID 1, and then the balance for this, and then token ID 2, balance for this. So in this case it was 0 and 1, so you get the point. But let's see what format this gives us the actual amount to, and do we have the token ID? Yes. Then what we will do, we could probably do result. Let's see, we call it dot result. Yes, it will be, let's call this data. We'll do data dot result, and this is an array, so we're gonna map. And this will be the, or we could just call it element. Well, in this case, it would be reduce actually. We would have, let's see, object, and we would have current element. So when they populate this object for each element in the array, so we're gonna do, let's see, object for current element dot token ID is gonna be equal to current element dot amount. We'll have to set this to a variable, so let result be equal to this. We'll console log result, and then we can also return result. I want to see if I thought about this correctly. So we're gonna run get owner data there. Yes. All right, let's try this. Okay, so it's undefined. Well, first of all, we can see that number of owners has actually changed now. So the number of blocks have increased, and the transaction is now confirmed. But this didn't work yet. So let's see what I screwed up here. First of all, we need to return this from within the reduce function. And then I think since we want to create an object out of this, normally this just accumulates some sort of value, right? But we want to set, we use it instantly as an object. So we'll pass in as well the initial value of this final object, and we'll set the initial value to an empty object so that we can actually use it as an object here. And we return that, and let's see, 1. That's not right. Oh yeah. Of course, we need to return it over here. Return object. We can't return this statement. There we go. So with token 0, I have balance 1. With token 1, I have balance 2. So now, since we return this data, we can access it here. So we have this owner data here. So when we render inventory, I'll also pass in owner data. And then we'll go to render, and we'll use it here. Add another row here, and we'll say your balance. And this will be we have owner data here. We'll set your balance will be owner data for the NFT dot token ID. See if this works. There we go. Your balance 2, your balance 1. And if I change accounts, well, I actually didn't implement the account switch logic yet. So even if I switch accounts, it will still be signed into the right user. But we have other tutorials for that on this channel on how to work with the wallet switching users, because when that happens, you want to sign out your user, sign in the new user, or you want to ask the user, do you want to merge these accounts into one? So I'll leave it here for this NFT tutorial. You can check out the other tutorials for that. But here is the final version of our NFT manager. We can mint, we can transfer, we can see all of this, see our image, our metadata, all of that good stuff. So we've come a long way, and it's so easy to do with Moralis, even though it seems a lot of work, but it's insane that we can do this in a couple of hours, and we got the full NFT manager. We've created our contract, we've minted it. It's absolutely crazy. And maybe some ideas to add into this could be a mint page where you can mint something from scratch, where you can upload an image, you can upload the metadata, all of that, and you can mint it from scratch. So that's a fantastic idea. You can also implement the Moralis IPFS system to mint using our IPFS, and you can upload your data there, and you can get the data there into your smart contract and so on. That would be pretty cool. If you have any questions about this, feel free to leave it in the comment section below. Otherwise, I'll see you in the next video. Make sure to subscribe to this channel, Moralis channel. Hit the like button. We'll appreciate that. Thank you for watching.